Hi everyone. So on this screencast, we want to take a look at question 3 on course activity 1. So question 3 is where we introduce rate of change. And so there is sort of a missing piece on the activity for defining rate of change, which is what we want to talk about here. So on the activity, you're given this scenario where the population of two countries was observed between the years 1980 and 2000. Population of country A increased by 2 million between 1980 and 1990. Whereas the population of country B increased by 2 million between 1980 and 2000. So the question is, if we were to define rate of change, which country would we say has the higher rate of change? It's just sort of from our intuition, which country would we want to say is increasing at a higher rate than the other? So that's sort of what I wanted you to think about in question 3, part A, is just try to make sense of that for yourself. So let's take a look at some data here. So for instance, if we looked at, say, two countries, say they both started with a population of 4 million in 1980, then we would say that then this first country, country A, increases by 2 million between 1980 and 1990, so we get up to 6 million. And country B increases by 2 million between 1980 and 2000, we get up to 6 million. So on our output side, our countries look exactly the same. They go from 4 to 6 million. And so this is where we want to be really careful about only looking at our output doesn't tell us the whole story, because we know that these countries aren't changing in the same way, because country A went from increased by 2 million in just between 1980 and 1990, so in 10 years, whereas country B took 20 years to increase by that 2 million. So if we were going to define a rate of change, it should be one where we would say that country A is changing at a higher rate than country B because it's increasing by 2 million over only 10 years, whereas country B is increasing by 2 million over 20 years. So let's take a look here at what this looks like on our graph. Let's just move our axes to be where we want them to be. So we'll go from 1970 to 2010. So we can see our points. And then our y-axis, we can go from 0 to 10, for instance. Now, you can see that when we look at country A, it goes from 4 to 6 over this 10-year period. So if we see we have 10 years and it's going from 4 up to 6 in that time. Whereas we look at country B, it's starting at 4 as well, but it's taking 20 years to get up to 6. So if we look at the difference in those two, if we think about a line going through those 2 points, and we look at the difference between those 2 lines, notice this one looks steeper than this one. So country A's line looks steeper than country B because it's getting up to 6 faster. So it's going up faster to the 6. It's going up over only 10 years instead of over 20 years. So the question is, what rate of change are we going to define? So how are we going to come up with a number that tells us something about the way these countries are changing or about the way data is changing? Well, what we do is we take the change in the output and divide it. I'm going to do this line for divided by the change in the input. So this y values there are output values, and these guys are input values, these x values. So we take the change in the output and we divide it by the change in the input. So for country A, for instance, country A, the change in the output, country A is increasing by 2 million between 1980 and 1990. So the change in the output was 2. divided by the change in the input, which was 1990 minus 1980. Okay, and so we would say that's 2 over 10, and that would be equal to 0.2, which you could see it calculated earlier for this. And it just shows that because I'm putting in the equal sign, so it doesn't like that. It doesn't know what to calculate. For country B, on the other hand, again, our change in the output is again 2, but this time our change in the input is going to be 2000 minus 1980. So you can see that our number, that when they calculate that, it's turning out to be 0.1, so it's lower than our 0.2. And the way you get that is by saying that's 2 divided by 20, and 2 divided by 20 is the same as 0.1. So anytime you're going to look for, you're asked to calculate rate of change, you're always wanting to calculate the change in the output divided by the change in the input. And you can calculate the rate of change between any 2 points. So in these tables, we happen to only have 2 points. But on a table where you have more, you can calculate it between any 2 points. And then that tells you, as you're going up the table or down up the table, you can see what's happening to your rate of change. So for instance, if we were to add a table, and say our table went 0, 1, 5, 10, and we started with 10, and then we went up to 15, and then 35, and then say 60. We could look and see what's happening to the rate of change in that table. So we would say the difference, we would first calculate on the first one, change in output, so 15 minus 10, oh, oops, I want to put parentheses around that so it keeps it all together, over 1 minus 0. We can see that that's 5, so that's our answer there, is our rate of change is 5. Then the next one would be 35 minus 15 over 5 minus 1. So we can see that that's 35 minus 15 is 20, divided by 5 minus 1 is divided by 4. So 20 divided by 4 is still 5. And then if we did the next one, we would see that it's 60 minus, oops, I got parentheses, 60 minus 35 divided by 10 minus 5. And again, we're getting 5 there. And if we were to look at the graph on this one, so if we went to go back to look where we're going 0 to 10, so say minus 1 to 11, and we would go from 5 to 65. If we look here, we can see what our data looks like. So we have our green data here. We look over here and we see that our points line up on this nice straight line. And that's because the rate of change between each of those points, even though there's different lengths between them, the rate of change is always 5, which tells you for every step in this direction, we're going up by 5. So when I take 4 steps in this direction, then I'm going up by 5 4 times, which gets me up here. When I take 5 steps in this direction, then I'm going up by 5 times, which gets me up there. And so we can see that although we have different gaps between our points, the rate of change is the same, which means they lie on the same line. Now, if I change this last one to 70, for instance, instead, maybe even say 100, obvious, then we would change this last value here to 100. And then we would see that these two have the same rate of change. So I have the same rate of change here. They're going through this nice straight line. But then when I go to this next one, I'm jumping way up here. So this rate of change has changed. My line is getting much steeper because I'm jumping way up higher than I was before. See,